Say hello to my new little friend, the Yaesu FT101E. Now, it's like me, it's a hybrid. I'm half Greek and half Dutch, and this beautiful transceiver is half solid state and half vacuum tube. Well, not half vacuum tube, but certainly the final stages for the PA. The stuff that generates the grunt is still a vacuum tube, and everything else is solid state. Lots of FETs. And it's the same vintage as I am. And I've had a quick look internally, and it looks probably in about the same condition as me. Its internals quite corroded. Look, for something that's over 50 years old, we're not expecting a miracle. And I think it was stored or lived somewhere where there was a lot of salty air. So we do not know what's going to happen when we power this thing up. But at the moment, I can't power it up because I don't have a power cord. Now, I'll quickly swing this around and we'll have a discussion about the connector that's on the back of it. For all of those people that haven't actually seen one of these, the connector on the back is quite old school. Give me a moment. Now, before we get into the internals on this, I'd just like to say the voltages inside this equipment are deadly. And I'm by no means an expert, and I am by no means saying follow along with me. I think you should do your due diligence. If you haven't worked on vacuum tube equipment before, maybe seek out someone that does know a little bit more about it. I am going to go slowly and carefully. These things can even have voltages inside them when they're not plugged in due to the large charges that are stored in filter capacitors and whatnot. So you proceed at your own risk. Okay, the connector on the back of this device is called a cinch Jones, and it's really, really old school. And the power cord that fits over that connector is quite hard to come by and quite expensive. I'll just show you some of the prices that I've seen quoted. Now, I'd love to be able to spend that sort of money on a connector to restore it to its previous glory. The plan is to actually use a modern style connector, and I know some people will be absolutely horrified by this, especially the people who are very pure in their notion of how gear should be restored, like for like. But let's face it, when you're changing capacitors in these things, you're using modern components. And what I'm going to do is I'm hoping I can get this connector inside the rig with a very, very small amount of modification. It might only require a couple of small drill holes. And I will attach this cinch Jones connector somewhere on the rig so that if the rig ever falls into somebody else's hands and they feel so compelled, they can reinstate this connector and connect a proper power lead to it. I'm going to use an IEC connector, which is a modern style connector. That's just like your kettle or your jug or your computer connector. So I'll be able to find a plug and cord for it more easily. Now, I was going to also, on the back of this rig, install a couple of rather large DC power poles so that were I to find myself in a position where I, had 12 volts available, I could actually plug into that as well. Now, having a look at the back of this machine here, it's tempting to think I might actually install those connectors, but then I have to drill out holes and do a lot more damage to the back of the rig. And so I've rethought that. And because I don't have to do too much damage to the rig to actually install the IEC connector, I will try and leave this rig such that it can be restored to a state of maybe not pristine originality, but originality nonetheless. So we will not be installing that. But I have purchased, just give me a moment, I'll go grab them. I have purchased these 500 volt electrolytics, the main electrolytic filter capacitors. And so I'm thinking that these are worth putting in. I've got them. I've got a decent desoldering station. And then down the track, I may very well change the electrolytics on the rectifier board, but we shall see. What I do want to do is get this set up. I don't own a Variac, so I'm going to have to take the risk and throw caution to the wind. I know there's ways of getting around that using an incandescent bulb and all that sort of stuff. I'm just going to pray to the gods of Yaesu that we don't let any smoke out. Okay, time to strip it down. Capacitors up here, so when I'm looking for them later, I'll know what they are, because we're just losing stuff all the time. Okay, I will get this lid off and I'll just show you the inside of it. It's seen better days. Better not sing that too much. We'll get a copyright strike. Lots of surface corrosion. I had to put a screw in this cage. It didn't have all the screws. It's still missing one over here as well, but it can't swing across like it was before. Now these capacitors, as you can see, they're very, very tall, about probably 3 times the height, but I was told, and it looks like they are, the same diameter. So we'll be able to use the same hardware to install them. So I will be changing those capacitors. I think they're 100 microfarad and these are 150, but I've been told online that that should be fine. So we'll get this stripped down and get it out of its case, and we'll go from there. Now I will go and grab a small container to put all the screws in, because I know if I don't do that, some will disappear. There's already missing screws, and that was not me, that was somebody else. Bad technician that I was when I was repairing scales, way wrap labelers and all that sort of stuff when I was working for Wedderburn Scales. The worst thing you could see was when you arrived at a place and the local service person or engineer who knew nothing about the gear had decided to go in and start playing. And of course you'd ask them what they'd done, and they'd always be very sheepish about it and say, oh, I haven't touched anything. And you know, they've gone in and played with every single pot that they could find and not noted where the actual pots were and position wise. So the chances of getting the gear to actually work like it should after they've done that, you know, on a complex piece of gear is next to zero. So I'm hoping that none of that skullduggery has happened on this thing. We shall see. And I will take a photo of what it all looks like, because there's nothing worse than taking something apart and then realizing you actually can't remember how it goes back together. And I will also have to note our positives and our negatives and all that good stuff as well. So we will have a crack at that now. And that's how, I'll just get some light on the subject. That's the bottom of our filter capacitors that we need to replace. And of course those resistors there are bleed resistors to bleed off any voltage that's there. Turbines to speed. Well, we've managed to disconnect this one on the left-hand side. We'll do them one at a time. I don't trust myself doing them both. I always lose my way. Always get good to get the right screwdriver for the right screws, lest you strip heads. I was starting to struggle with the other screwdriver, and bitter experience has taught me not to do that. Even if it takes a little while to find the screwdriver you're looking for, it's better to do that than proceed. That's the screws that hold the capacitor in place. It should just lift out now. I'll just put those in the corner of this tub. This whole thing should just lift out, which it does. And these are 500 volt, like I said, 100 microfarad. I've got 150. They do look a little bit charred in places, but it doesn't look like it's domed or bloated, so it's probably all right. But you know, we've got new ones. We might as well pop them in. You can probably see here, you just undo this screw here and that should slide off, and then you can fit your new capacitors, and then it'll be the same on the other side. I have to work out polarities. That's the only issue. Well, there you have it, folks. 2 new capacitors. Out with the old, in with the new. Now we just have to work out what's going on around here, around this Cinch Jones. There's a lot of wires coming in there. I'm assuming some of those are for the 12 volt option. Some of those are probably for different voltage options for different countries. and we need to make sure that we get this set up correctly and that it is set up correctly for 240 volts or 230 volts, which is what we're using in Australia. And this is on page 173 of the service manual. And on the bottom right hand side here, you can see the pinout for the 234 volt option. And it would appear that our rig is unsurprisingly wired for Australian conditions. So we just have to now work out which wires we need to pinch off the cinch. Okay, massive change of plans. I started looking at this cinch Jones connection and at the actual schematic diagram, and this point here is a real nexus for various things that happen in the rig: fans, power switches, etc., etc. And making good of this once someone actually manages to get hold of a proper power cable would have been a real nightmare. So I guess the purists out there will be very happy to know that, or maybe they're not. What we've done is soldered to the back of this so that these can be taken off and cleaned up, and you'll be able to get the connector back on there. What I'm going to do is I'm going to put my mains cable on here. This is wired up like the back of the plug would be wired up if I had a plug. And the plan is to 3D print a box here with some strain relief in it. And I'll be able to then put that box over this to make this a lot safer. For the time being, I am going to tape it. I could heat shrink it. I may actually heat shrink it and just cut the heat shrink off when the time comes. That'll be harder to get off, but it's probably a lot safer. As an interim measure, like I said, I will shroud it with heat shrink. We'll get to see if this rig powers up and see if any smoke comes out. So that should be fun. Now, this is the way we've wired it up as per the Yaesu plug. And active and neutral, which side is hot? The way I've worked that out is I have gone to one side of the fuse and we don't have continuity, but when I flick the power on, it's giving me continuity to that point. So that is the active line. Now, were I to go over here to the one that's neutral and try the same deal, switching does not work. So active is the top center, neutral is the one down from the right hand side, according to my calculations. I will double check on the schematic as well. And the one below that is an earth. How do I know it's an earth? Well, if we grab our chassis, which is where we want our earth to be going to, and we touch here, we've got earth. And we don't have earth on that neutral line. So that is case, the earth. So I am thinking I will quickly have a look to see that the active is the fused line. Sorry, the switched line, which is the normal situation, but I will double check that. So I figure while I've got the covers off, we'll just give it a little blast with the air gun. Not too harshly. Now, some of you may be thinking that why is this guy wiring up the back? Why doesn't he just go and buy a female plug? Well, I've gone on Mouser, and there's heaps of male ones, but there's no female ones. Way of the world. I am assuming that people have actually gone and purchased all of the female ones to make up power cords so that they can sell them for $50 or $60 on eBay. I did manage to find some actual female plugs on eBay and places like that, and they're like $40-50 US before they're delivered. So I ain't doing that. One may turn up secondhand at some point in time, which would be great. But you know what? If I can get this thing going, however I get it going, as long as I haven't murdered the back of it too badly, I will be a happy chappy. And let's face it, we might switch this on and see a plume of smoke and it's game over. Who knows? But we're about to find out. So give me a few minutes. We'll get the plug all wired up and shrouded, and I'll put a cable tie on the back of it so it doesn't pull out of the back of the set. I'll show you that when it's done. Okay, we have this such that, this is not the finished product, people. So please do not make Widowmaker comments. We are going to shroud this correctly and make it safe. But we have strain relief on here. We have this all covered so that we're not going to inadvertently grab it and electrocute ourselves. And we are now going to plug it in and see if the magic smoke comes out. Okay, folks, I almost feel like I should have a fire extinguisher and a crash team ready. I'm hoping that, I think switch up is on, but we have this plugged into a dummy load, and I'll just make sure that our heater is off as well. It's in push to talk, so that should be good. And let's just wind our carrier and our light gain back in case it does jump into transmit. Let's plug it in and say a little prayer. Can I have a clear prop? Fan started. No smoke. Dial lights are on, VFO light is on. So cannot hear any sound. Something's happening. Mode switch. That's in 40 meters. So definitely a dodgy mode switch. Let's plug it into an antenna and see if it receives anything. That'd be fun. So noisy pots, mode switch is playing up as well, so we might try and clean them. This is 80 meters. I'll pop over to 40.
Places like that, and I'm trying to think of the other place that like so many things do escape you these days, mate. The brain just
Clarifier.
He was really, really good at writing stuff, and one of the issues that I always struggle with logging that is that useful little program having that utility.
So a couple of Australian, South Australian stations, VK5s. Something that's really always annoyed me is that mics plug in the front like they're more important than a key, and keys plug in the back. Maybe it's because we always have the key in and we don't need to take it in and out. That might be the reason why. And hopefully we don't have any smoke come out. Well, I actually hit the heater and I did see the one of the tubes light up. So the cathode's coming on. Yep, all the cathodes are coming on. But I have no idea how to tune this rig. So I am going to go and look at the procedures and write them down because they might be a little bit different. Okay, folks, we're heating up the cathodes. Driver tube is lit up, which is nice. And we also have both of our final tubes lighting up. Oh, that warm glow. And we are trying to set the resting bias And with our adjustment here, our bias adjustment, when you crank that to completely clockwise, you're barely moving the meter. So with it to anti-clockwise, no movement, and completely clockwise, sometimes moves, sometimes doesn't, which could be the actual pot. But I am thinking that this regulator board has issues with component values. There you go. Comes and it goes. I might give it a deoxit, see if that makes a difference. Okay, we've hit it with some deoxit and had a little bit of a twiddle and a fiddle. We're getting about 50 watts out, so I think the tubes are pretty soft, I would say, but you know, I haven't checked any voltages and bias and all that sort of good stuff. So what I think I'm going to do is, I think I am going to recap that board, do some voltage checks, but we might just leave the video there. So 50 watts CW, which is, you know, a good amount of power for me on CW, and the rig is going to be used on CW anyway. So being as these sweep tubes are quite difficult to come by, I will keep an eye out for an affordable set.
Why would you want to be on the dark web? What is dark web? Oh, exchanging, you know, cryptocurrency to people to buy stuff overseas.
Wow, still here. Thanks for sticking around right to the end of the video. And remember, if you did enjoy the video, drop me a like and maybe hit the subscribe button. Make a comment. I've really enjoyed playing around with the FT101E, my first ever Yaesu rig, and it's great to have another hybrid rig in the lineup. Admittedly, the tubes are a little bit soft. We're only getting 50 watts, but 50 watts on CW, that'll be enough. Over the next few weeks / months, I'm hoping to do a little bit more work on that rig, and I've got a lot of other projects in the pipeline. So keep an eye on the channel for all that great upcoming stuff. 73, and I shall see you in the next episode of The Art of Engineering.